Wait, hold on. 90% of AI applications still fail because you have not used this. So in 2026, if you're straight away plugging in your LLM model directly to your AI application, it might fail. So you need to see this particular video. So model on its own cannot do all these. For example, remember what happened in your previous prompts. So remember in ChatGPT or Claude or Gemini, you've given one prompt, and then the next prompt, when you give, it remembers the previous prompts and it answers based on your previous prompts. So model on its own, the LLM model on its own cannot remember. So this is one point. The second is it cannot call, the model cannot call other models on its own. So for example, let's say you have a fleet of AI models. Let's say one model is dedicated for web scraping, or one model is to OCR for text to image to text conversion, or any other sub models that you have. Let's say you have a very good graph, but LLM model on its own cannot do all that. So yeah, and also a LLM model cannot on its own call other APIs and services. LLM model cannot recover something when it fails halfway. It cannot store logs for enterprise on its own. It can't do verification and safety guardrails on its own. So we need to build this. So let's get started. Why does the raw LLM fail in production? So again, lack of system guardrails, the context limits and degradation, long sessions would lead to context overflow and model confusion and lost instructions. There would be system guardrails which would not be properly inbuilt to the LLM model. The failure loops would not be automatically inbuilt in the LLM model. So what we need is some sort of a harness. We need to support the entire infrastructure around the LLM so that it can give us the best results. So we need a harness solution. So in LLM, it's called harness engineering. So harness engineering is all about the infrastructure around the LLM which would support it, just like on the image shown. So we need to have something, the infrastructure, the memory and everything around the AI model, so that we can do all sorts of things like memory, tool calling, other model calling, other API services calling, everything. We need to have a proper library for it. And here comes the LangChain. So LangChain is an AI open source framework. It is the agent harness. Harness is what differentiates from a normal LLM with a proper production agent. So let's get to it. So raw LLM versus the harnessed agent. So the create agent is from the LangChain. So first difference is the stateless memory. So raw LLM is stateless. It cannot remember the previous conversations that you had, previous sessions. It does not have a proper session ID. It does not have, it's stateless. But whereas if a harness agent will have a short-term memory in memory checkpointing, so it will save all the information. It will have the short-term memory, whatever in session you have discussed, it will remember that, and based upon that, it will give us the results. So again, there is this difference. Then again, another difference is tool orchestration. So for raw LLM, manual schema mapping you have to do, like it's a hassle, but with the help of harness agent, there is a middleware agent for tool lifecycle. So it would do all tool orchestration on behalf of the LLM, which is better approach than planning and subtasks. So raw LLM is just one input, one output. But whereas a harnessed agent, you can do loop engineering. Whereas let's say you give a prompt to the LLM agent, it would, let's say, call another tool, or with the harness agent, it can call another agent, or it can call another service, or it can do DB queries. It will do all sorts of things. Again, it will go get the context. It will give again back to the LLM model, and then again it answers, and it can and it can do until the desired output is received. So it can do iterative execution loop with the help of harness agent for better results. Then again, one more is context management. So if you're using the Raw LLM API, then you need to do everything manually. But whereas if you have a proper agent, then it's a middleware, so it's compaction and everything. It's all the context window. Everything is handled by the harness agent. In here case, it's LangChain. What are the core components of the harness that we're talking about? Like state management is one of them. It tracks the history, checkpointing, and basically memory, the short-term memory, and it can maintain the session IDs. So with one session, like for example in ChatGPT, you open a window and then there's a session goes with multiple prompts, so you can maintain a proper session so that you get better responses. So this is handled by the harness. So the Claude, everything, they built harness infrastructure around the model. So yeah, so that's how the state management is. Then there is tool lifecycle. So let's say ChatGPT wants to search the web and get some web searches. So for that, there is a tool internally it calls. So that is tool lifecycle. There is it will handle all the setup, teardown, authentication, runtime, sandboxing, everything, schema validation of tools, everything, whatever you need to call a particular tool and get the results and everything. So everything would be handled by the harness agent. Then again, it's a middleware stack, which let's say whatever business logic you have, or prompt compaction or stream handling, policies, safeties, guardrails, everything. So it's a middleware stack that would control everything based upon your business logic. So these are the features of harness. This is the reason why you need to have harness along with your LLM model. So yeah, what is LangChain middleware stack? So LangChain is like a tailored agent execution. So LangChain is an open source framework that speeds up building this app with this LLM model. So whatever that we've discussed so far with memory or tool calling and other model calling and everything is handled by this LangChain. So it has built-in memory, and LangChain has also another feature where you can switch the models. Let's say right now you want to use Qwen, or at other time you want to use DeepSeek, or if you want to use Gemini, or if you want to use Claude, your code will remain the same. You can just switch the models. So this is also one of the features of LangChain. It has easy connection to outside data and tools, and it has a better tools which will reduce your AI errors. So yeah, this is LangChain. So let's just quickly talk about the evolution of AI engineering. So earlier it was just was prompt engineering, where there are single prompts. There is it was using raw LLMs. Now we have, let's say, the second step was chain and tool use. So it would call basic tools using MCP and something, and earlier LangChain and RAG pipelines. So this was the second, and then now we are in a stage of, let's say, agent harness, which has the middleware stack. It can do proper safety guardrails, error handling, log saving, evaluation loops, and everything. So enough of theory. Let's move on to something real life code implementation. Okay, so in order to give you, so I've created two Python code which we're gonna use. One is with LangChain and one is without LangChain. So first let me run the without LangChain, and first let me run the output, and then we can I can go about explaining the code. So okay, give me a second. So let me run this AI app. First is without. So let's say let me ask, what is photosynthesis? Giving me an output something, and let me ask further what are its, let's say, just a follow-up question, what are its benefits, just to give you an example. So remember, okay, so I've asked the agent what is photosynthesis in the previous prompt, and then the next prompt what I've asked is what are its benefits. So ideally it should have remembered I'm talking about photosynthesis, but what it has given me an answer is nothing to do with photosynthesis. So here it has no memory. So here I wanted to depict that this particular LLM model does not have memory features. So here in this particular code, what I'm doing is I'm just giving the model path, executing it, and getting the prompt from the user, and just sending that prompt to the model, and the model is giving a certain output, and that output I am showing on the screen. So just to depict that the LLM model does not have that memory feature on its own, and it does not have other features like tool calling and everything. It's a simple question and answer. So here, as you can see, now let me exit and let me run the same with the LangChain code. So now the LangChain code is running, and I can ask what is again photosynthesis. So it has given me an answer, photosynthesis process which the plants convert. This, for understanding, just have kept it just for the sake of understanding. Okay, so this is there, and let me ask what are its benefits. It has given me, so if I'm asked what are its benefits, now it has given photosynthesis is a crucial process for its life form, and it has given essential role in sustaining the plant's complex ecosystem. So it understood when I said what are its benefits, it understood I'm talking about photosynthesis. So this memory management is happening over here, and please note that I'm using the same exact model. So with LangChain and without LangChain, the model is exactly the same. It is using the same model which is over here, and so you can see that the difference in usage. So okay, so let me go through the code. So first, without is pretty simple. I'm using llama-cpp, and the entire code is present in the description box. You can download it from GitHub. So I'm using just for dependencies, it's Python 3.11, and I'm using llama-cpp-python for without LangChain. And you can download this particular model from Hugging Face. You can watch my previous YouTube videos as well. And yeah, so this is it. And with this is the dependencies for without LangChain. Here I'm just creating an LLM object for llama. I've given the model path. NCTX is the context window that I want to have, and the number of threads is 4 based upon my CPU. Verbose false is I don't want logging, I want clean output, so I don't need logging, so that's why false. And while true is iterative, all the time I want to keep on calling, so that's why it's while true. Whatever input I'm getting, I'm putting it in the user variable. And so if I'm giving exit, I'm breaking off this while loop and closing off the session. That's it. And output is just calling the LLM model, and here user is the input, and it's just I'm calling. Temperature I'm given as 0.7. so temperature is something, so let's say you want the LLM model to be more creative, you can increase the value. And if you don't want, so the more higher the value, let's say you give temperature as 1, it will give more, it will have more randomness to your answer. And if the lower the temperature, it will be more deterministic, so the same values it will give with this with the prompt, it will give the response will be this, it will be similar. So the lesser the temperature, more same answers you're gonna get, and the more higher the temperature, the more random and more creative answers you're gonna get. Max tokens is the output tokens, how many tokens I need as output, and then answer. Based upon this, I'm extracting the answer and then printing the answer. So this is without the LangChain. And now let's talk about with LangChain. So LangChain is again a library that you need to install via pip3 install LangChain. I'm using the LangChain community and LangChain Clue, and then since I'm using open source model, so Qwen 2.5. So here, in order to talk to that, I'm using llama-cpp. So it's similar to non, it's just that the LangChain supports this. So I'm using this particular function to create an LLM object. So here I'm just initializing the GGUF, this open source model, with llama-cpp. So here it's the same. And okay, so like I said, here it remembers the history. So let me go through here again, the same while true, getting the user input, and if it's exit, I'm just breaking it off from the infinite while true loop. And okay, so here, since it's LangChain, what happens is there's a session ID and there's a conversation chain that I'm creating with the model. So this is the session conversation chain, and here I'm invoking it. So first, in order to understand, is for each session I want to have a session ID. So my CLI session is a session ID that I have configured. So this is the session config. Here I need to specify that. And okay, so before I move ahead, let me just tell you about store variable. So I've created a store variable to store all the prompts, whatever prompt I have given, what was the output of the LLM model. So all that will go in the store variable. And okay, and the store variable will have each session's ID. Like CLI session was over here. So for my understanding, I've created this particular, I'm just printing it out. So let me do is, let me just copy this, paste and format. Okay, so CLI session, as I said, was my session ID. Within that session, I am storing everything. So all the previous prompts that I had, like what is photosynthesis, what are its benefits and everything. So this is the human message that was there, and then there is an AI message, which is the photosynthesis is whatever response I got, and again here. So this is entire thing goes under the session ID CLI session. So yeah, so this is in memory chat message history. And so yeah, so with this, and this entire output is the store variable output. As I keep on conversing with the AI agent, it will show more output over here. So this is one thing. So I hope you understood the value, the importance of store variable that I've created over here. And okay, so in this particular thing, so the store, and in order to retrieve all the session information with the help of session ID, I have to create a function called get session history. Get session history will take the memory chat history, and then it will check. So the input is a session ID. If it's not present in the store, it would create one. So with the same session ID name, it will create, and if it's not, it will create. If it's not, it will create. Otherwise, it would return store session ID. So store is a dictionary in Python. So this is for the retrieval of all the messages in that particular session ID. So this is one thing. And the next thing is, okay, so I need to create a template as well, a prompt template, which will be a placeholder for this store memory that I'm talking about. So this is a chat prompt template, and this particular chat prompt template contains a system and the human response. So if I go to, yeah, so there's this human message, the AI message, everything. So yeah, so there's a system, there is a human, and input is whatever input user gives. This is stored over here. System, this is a system prompt. This can be changed based upon the system prompt that you want to have. System prompt is a hidden prompt that you can give to the AI agent. So let's say if you want the AI agent to respond only in JSON for, let's say, MCP purposes or any other purposes, so here you need to give like system prompt that answer only in JSON or something like that. So all the system prompts will go over here. Input would be the human, and then again a message placeholder variable name history. So yeah, this is the prompt template that I've created. Then after that, I'm creating a runnable chain. So chain is equal to prompt. Here the best part is you can use a pipe symbol to like talk to the LLM. So here you can specify that. So this is like a runnable chain that you can create. So that's it. And then again, store explained over here. You can create in memory history and get the information in that based upon the session ID. And okay, now let me talk about the conversation chain that we have created. So when I want to create a conversation chain, so I need to use the function runnable with message history. Here I need to give the chain that was here. So this is chain, and then the get session history. So this is the function I need to pass over here for history retrieval function. So whatever the history retrieval function that I have created, I need to give as a second parameter over here. Then input key message is input. That is the this represents the new user message. So also the new user message will go over here. This is input message key, and then based upon the history where you need to loaded history needs to be injected. So that's the variable name history. So yeah, so these are the four parameters that you need to give in the conversation chain, basically the message history, and that's about it till here. And then the easier part, you need to invoke the so whenever you want to talk to the agent, you need to use the same conversation chain that we have created, and you can invoke it by giving the user input. User input is just right now we have given, and with the session config. So session config contains the session ID. So based upon this, you can get a response, and then that response you can print it on the screen. So each time when we are talking to the LLM model, it will have the previous history along with it. Yeah, that's about it. Please do like and subscribe. Yeah, thank you so much for watching.